Morning, everybody. My name is Jack Lazarchak, and I'm a developer at Chariot Solutions. This next talk is one I'm personally very excited for because actually in my free time I've been researching TinyML. You may have heard of this depending on how many Chariot talks you've seen, because some people at our company have done talks on that before. But essentially all it is taking a TensorFlow model, making it small enough that it can fit and run on a microcontroller. And this is usually used in a kind of low situation. And though it's very interesting, it's really made me wonder, if I can do all of this on this tiny device, imagine the possibilities when you leverage more powerful machines in the cloud. So here to tell us more about how to do just that and how to build resilient production-ready systems is Specialist Solutions Architect on IoT for the Americas at Amazon Web Services, Neel Mitra. And before I hand things over to Neel, I just wanted to give a big thanks to Neel and everyone watching remotely today for making this all possible. And though it's unfortunate we can't meet in person this year, I'm still very glad that we're able to do this and spend this time together, even if it's only virtually. So thank you, and over to you, Neel.
Thank you, Jack, and thank you, Chariot, for giving us the opportunity. So good morning, everyone. Hope all of you are safe and sound with your family. I really appreciate you taking time to join this session in the middle of this crisis. So thank you for that. A little bit about myself. I am a specialist SA on IoT based out of New Jersey. Have been with AWS for a little more than 3.5 years now, but it still feels like day one. So welcome to this session, Bring IoT and AI Together. I had been really fortunate, to work with different customers who build IoT and AI applications across different industry verticals. And I'm very happy to get this opportunity to share some of my experience with all of you today. So if you're passionate about IoT or AI or both of these technologies, you are at the right place at the right time. So let's get started. So what do I have for you in the menu? Let's see. So we'll start with an overview of AWS IoT services, but we'll primarily focus on edge computing, as Jack was mentioning. We'll also give you a quick overview of the machine learning capabilities on AWS. And then we'll see how the combination of these two technologies makes wonderful things happen. We'll also share with you, some reference architectures that is commonly implemented by the customers in different industrial segments. Seeing is believing. So I also have a quick demo for you. And finally, I will share some resources with you guys so you guys can get your hands dirty. At AWS, we start all IoT conversations with the simple question: if you knew the state of everything and could reason on top of the data, what problems would you solve? And the reason we do that, in the last few years, we kind of made it our mission to ensure that we build the right services and the tools and the processes to help our customers know the state of everything, every device they have, so that they can collect all the data from those devices, reason on top of the data, and can truly solve their business problems. Because at the end of the day, no one wants to buy another technology, right? All customers wants to buy business outcomes. So that's what we are trying to help with. And this is just a snapshot of some of our publicly referenceable customers. And if you think, they're spread across different industrial segments. So with Vizio, they have tens of millions of smart TVs that they launched end of last year. With GE, they have an Edge OS solution that is used for field assets like 3D printers and aviation and whatnot. With iRobot, they have their Roomba vacuum cleaners, which you guys might know, and that has more than 500 million square foot of floor space as part of the company's smart operation. And the list goes on and on. And if you observe that all these different customers are using IoT for all these different kind of purposes, right? Whether it's predictive maintenance like Kempe, they use it for their flagship welding machine, and that helped them to reduce the cost by approx 50%. If you think about Philips, they are doing wellness and health solution to solve the challenges of connecting all these healthcare devices across different hospitals. If you think about energy efficiency, customers like Enel, they're reducing the provisioning time of the assets from weeks to a couple of days using AWS services under the hood. So, customers are really enabling a lot of opportunities, a lot of capabilities using these services. And I'm very excited to talk to you about all of this today. And working with these customers, we realized that IoT solutions can get complicated because it's multidimensional. First, you have the edge layer, where this is where you onboard, operate, and manage your devices. Then you have the connectivity layer. You might be in a communicating over maybe cellular. You might be communicating over long-range network connectivity, something like LoRa, Sigfox, or you might have a very stable connectivity as well. So you have a Wi-Fi network like in the consumer homes and you are connecting. So there is a lot of mix in how devices can connect. And when they connect, on the cloud side, on the control plane, you have all these billions of devices continuously sending, probably trillions of messages, and you need a scalable infrastructure to process all these messages in different protocols. It could be MQTT, it could be HTTPS, it could be a UDP-based protocol and whatnot. And now you have all the data. You are not just doing this for fun, right? You want to ensure that you are able to analyze the data quickly, get the insight. And the problem with IoT is for many devices, especially those on the field, the data could be really noisy. So you need to have some capabilities to quickly filter out the noisy data and get the insight. So analytics plays a essential role in IoT as well. And then you build a lot of different kind of applications, right? It could be like the APIs to help third parties to consume the data, or it could be business consumers and whatnot. So the obvious question is, okay, that's great, Neel, but how does AWS support me with all these different building blocks? And that's what we kind of refer to as the fundamentals of AWS IoT. So what we did, we tried to simplify this into 3 different stacks. So at the device layer, we have built device softwares, which helps you to connect your devices and operate at the edge. Then at the communication layer, we have control services, which helps you to control and manage and operate billions of devices on the field. And then on the data layer, the obvious question is, okay, this is great. I have all my devices, and how I can quickly analyze all the data that I'm getting. So what we did in the last few years, we built different services at different of this layer. So at the edge layer, which is the bottom of the layer, we have services like FreeRTOS, which is for microcontrollers. And Jack was mentioning how you can probably bring something like a tiny ML to microcontrollers now, and that would be going to be awesome. We have IoT devices SDK. So if you have connected devices and you just need an SDK for those devices to talk to the cloud and do some processing, then yeah, we support like Java, Python, Node.js, and all those different kinds of SDK that you can just use. And then we have Greengrass, which is a very powerful solution for the edge, and it brings a lot of capabilities, including local compute, local messaging, machine learning inferencing. And in today's session, we're primarily going to talk about Greengrass because that does a lot of things on the edge, and we'll get to there soon. On the control layer, we have IoT Core. That was the first service we launched in 2015. So it's kind of a gateway which support billions of devices, and it has different microservices under it. So it has a identity service for handling all the auth-C and auth-N. It has a routing, so you can create rules to route all the data to different kind of backend services like Elasticsearch or NoSQL solutions or a real-time stream and whatnot. And now you have a way to collect all this data from all these billions of devices. The question is, okay, how do I manage it easily? So with device management, you can kind of group all these different devices into hierarchies and can serve different kind of consumers, internal or external. It could be segregated by geography. It could be segregated by your line of products and whatever you want to do. So you can do that using device management. So this is great. Now you have all these devices able to connect, you are able to manage. The next obvious question is, these devices are on the field, they're pretty vulnerable. How do I ensure that I have a continuous DevSecOps pipeline for all these devices to be monitored, that they're secure and they have not been tampered with? So that's where we have a service called IoT Device Defender, which helps you run different kind of audits or even build a real-time pipeline to kind of analyze all these different kind of metrics and mitigate those in kind of before it kind of damages you. Things Graph is a service that we have built for quick prototyping. So many of our customers told us this is great, but we need a faster time to market. Can you give us, service where I can kind of plug in all the different APIs, different hardwares with the IoT services, and I'm ready to go. That's what Things Graph helps you with. And finally, at the top of the layer, we have built services like IoT analytics, which is, helps you to collect, pre-process, enrich, and store data in a time series optimized data store. It has a ETL pipeline to help, enriching the messages, filtering the noisy data, and it's pretty flexible because you can bring your own code as well. IoT events helps you with, handling operational events. So this is essentially a state machine where you can say, based on the state of my device, these are the set of actions that needs to be taken. And finally, site-wise is an industrial service that we have built. So if you think about OPC UA data, you can just stream those data through a gateway to the cloud. And site-wise, we'll do the deserialization of the OPC UA data to standard JSON messages. And from there, you can continue with the story of Industry 4.0 and have an industrial data lake and process the data for various purposes. So with that background, let's just, to be clear, when we think of this, 3 different stack, we do not think of it as a standard 3-layer. We think of it more as a, flywheel, because this is not a one-time process. You are building all these capabilities, you are deploying to the edge, and from the edge, you are continuously collecting data. You are learning from those insights. You are fine-tuning your data, your models, your compute, and then again, deploying back to the edge. So we like to think of it as a virtuous cycle rather than just a 3-layer stack. And in this session today, as I mentioned, we'll primarily focus on the device layer and on Greengrass. So device layer or edge computing. So you might be thinking, okay, we had cloud computing. Why do we need edge computing now? Why can't cloud computing solve all my problems? So working with all these customers, we realize that vast majority of the machine data may never reach the cloud for different scenarios. So if you think of examples like regulated world, like hospitals, you have constraints where the sensitive data can go. If you think of industrial machinery, they cannot afford the round trip latency from the cloud. If you think of extreme operating environments, like the mining sites and aircraft in flight, it can really expensive to move all this data to the cloud and bring it back. And that's where we realize that we cannot just rely on technology to solve these problems. And we talk about these 3 laws. The law of physics, we can't beat the speed of light yet. So for use cases where your autonomous vehicles is in a tunnel and they need to take a turn or they need to avoid a crash, you cannot afford the round trip latency from the cloud. So you have to do things locally. Law of economics. The cost of network bandwidth is not falling as fast as the cost of storage and compute. So you are paying for all the bits and bytes that is going to the cloud. And finally, law of the land, like the regulatory law, data cannot leave my region, my hospital, my factory, my premise, and whatever. So for all these kind of scenarios, decision-making must continue to be executed locally on the device. And if you think of a customer like Neel that I referred earlier to, they are collecting sensor and meter data from over 500,000 cabins distributed across the territory to measure different kinds of energy consumption and monitor network behavior in real time to track effects of seismic waves and earthquakes. And this project is widest so far in Europe and sees a lot of opportunity to design a better future. I am just hopeful that someday we have a technology to detect all the viruses and we don't have to go through this crisis again. So fingers crossed. So how do edge computing works? How does a rubber meets the road if you use AWS services? So that's where Greengrass comes into the scene, right? It provides 3 core use cases. So you can do a lot of local actions and remote control. It does machine learning inferencing on the edge. And it also supports with ETL processing. So you can do a lot of extraction, aggregation, and transformation on the edge because you now don't have to send all the data to the cloud all the time. So let's go a little deep into Greengrass. So what is Greengrass again? Greengrass is a software. So it can run on different kind of hardware options as long as it's x86 or ARM architecture. It can run on different versions of Linux. So you can see the names. If it is not Linux, it also offers as a container. So you can run Greengrass in a container in any kind of environment you want. And once you have Greengrass installed, you can bring your application logic into it as Lambda, which is a serverless function, or it could be Docker containers. So if you have a lot of business logic that is existing today and you want to bring to the edge and run it, just containerize it, deploy it over the air, and Greengrass will run it for you. So Greengrass is more for microprocessors though. So you need at least 128 MB of RAM and 1 core of CPU. And it gives you capabilities that you need in a more powerful device or a powerful gateway appliance. And that can talk to many other local edge devices as well. So let's get into that. So what are the foundational components? Firstly, local message and triggers, right? So it brings the local Lambda compute, local container compute, local messaging broker, local device shadows, as well as all this communication that is going to happen is secure because they all use TLS and mutual auth. So now you're essentially getting the software capability for the edge. On top of that, you are getting the different kind of compute runtimes. And with Lambda, in case you have not used it, you use distributed programming languages. You don't have to do embedded programming anymore. So you do not have to have two different code bases, one for the embedded guys and one for the cloud guys. So the same code base can be used both in the cloud and on the edge, which is great. And over the air updates. So you don't want to go into all these mining environments or if the aircraft's in flight and kind of, plug in and plug in an USB and update it, right? So over the air update is super crucial for different customers who are considering edge computing. So let's go a little bit deeper. So with IoT Core, which is our control service and our first service, if you remember, that we launched a few years back in 2015, it offers all the MQTT PubSub brokers, the gateways and whatnot. So with Greengrass, we try to do the same thing. We are essentially bringing a lot of these cloud capabilities to the edge now. So you have an MQTT PubSub broker on the edge, that can talk to hundreds of devices, actually 200 devices, and the limit can be increased in the future. And you can deploy Lambda functions on top of the container that could be written in Java, Python, Node, as I was mentioning. So now with this example, if there's an autonomous vehicle that needs to, kind of detect that detects a pothole on the road, and it can use vehicle-to-vehicle communication to notify everyone else completely offline mode. And with that, the other vehicles can take whatever actions they need to take in terms of changing lanes or whatever it is. So everything can happen offline without any cloud connectivity in this kind of scenarios. The next one is local resource access. So the obvious question is, okay, I need to have access to different kind of GPIOs, not only sensors, but I might have camera taking the pictures and the videos, and I might need to do, processing on those. And that's great because, with Greengrass, it has support for both CPU and GPU rendering. So you can collect different kinds of data. You can process that locally. You have access to the local file system. So if your devices has more capability, you just put more capability. There is no up limit for Greengrass in terms of sizing. Security is our top priority. I talked about TLS authentication. Greengrass also supports something called PKCS, if you have heard of it, public key cryptography standard. That means your private keys are most vulnerable if the devices are in the field. And if you can have a trusted platform module on your devices, which stores the private key in different secure slots, no one will be able to tamper with your private keys, even if your devices are compromised. So there is a security layer. And also there is something called secret manager that I will talk to you about. So now let's talk about the enhanced capabilities. Those are all foundational stuff, right? So now I was talking about machine learning inferencing. With Greengrass, you can deploy your machine learning models to the edge, and you can do the inferencing with CPUs and GPUs. And you can even connect your edge devices to not only AWS services like S3 or Kinesis or IoT Analytics, etc. If it is in a completely offline mode, maybe in a factory or in an industrial setup, it might need to talk to local services. So you can talk to, let's say, like ServiceNow or Twilio or Splunk, and all these connectors are built in to that. You can deploy functions and containers, as I mentioned about. Stream Manager is something interesting. Previously, customers, when they wanted to do a lot of ETL processing on the edge, they had to build that orchestration themselves using a combination of Lambda and containers. But with now Stream Manager, we provide you guys with the API, which you can just use. And then, voila, you can do a lot of stuff, lot of business logic, focusing on the business logic as a developer, rather than firefighting and doing that orchestration at the edge. I also talked to you about the whole security aspect, where you can, have all these different kind of applications now running on the edge with Lambda containers. But with application comes also the secrets. How do you ensure your secrets are encrypted as well? That's where Secret Manager comes into the play. So you can keep your secrets that will be used by your applications running on top of Greengrass secured from the cloud to the edge. So let's move forward. So container support, we support Docker today. So, as long as you have a Docker image, you can just use the same CI/CD methodology that you have today. You can check your code into Amazon Elastic Code Repository, which is our repo for the containers, or you might have a private one as well. And then you can deploy all those containers to the edge. Stream Manager, I was mentioning that, it extends essentially the local processing with far more capabilities. So now you have, control on setting policies. So you can say that this is my high priority stream and this is my low priority stream. And whenever my device gets connected back, I would like the high priority stream data to be published to cloud versus the low priority stream can wait because it's probably aggregated data and I can store it for some more time. You can specify timeout behaviors, and also you can extend using Stream Manager to different cloud services, or you can continue to use the same MQTT path to send all the telemetry data that you do for other devices. So you have both the options. Machine learning inferencing. So now you have access to raw data or even the transform data with Stream Manager on the edge. You can perform machine learning inferencing without additional data transfer cost or even increased latency. That's awesome, right? So far, like machine learning and inferencing has been mostly a cloud thing because you need, the horsepower that you need to use for, training the models, building the models. Well, you still do that. But for the inferencing, it can go to very miniature devices. Like here, we're talking about Linux-grade devices. But when we started, Jack mentioned about TinyML. So in the future, or even now, with many use cases, you can just deploy machine learning models into microcontrollers as well. So that is awesome. And we have service called SageMaker Neo that we'll talk about, which helps you to optimize all these machine learning models for the edge. And we have a growing partner community for the edge. So if you have to build real world application production grade with production grade hardware and solutions, you cannot do just like with a development kit, right? You need like production grade kits for your production grade solution. So that's where you can work with all of these different partners that you can see to help solve real world problems. So with that background, let's now bring on artificial intelligence. So let's switch gears. And you had been hearing me talking about how you build and train your machine learning models and deploy to the edge. But then what is the process to build and train and deploy to the edge? How much effort is it, right? So we'll see that. But let's take a step back because I want to give you some context. I don't know if you guys have seen this website. This is the Amazon.com website from 1995. If you don't remember anything about this presentation, probably you will just remember this. And you see the logo is quite different. So we used artificial intelligence since 1995 when it was not even considered cool. And you see this feature called eyes and editors that we had. So as a reader, you could have subscribed to certain authors and genres, and the AI engine will match your interests and send you notifications from time to time. And that culture of machine learning and AI, deep learning continued across different services that has been built on top of Amazon. So if you are doing a product search in Amazon.com, you see different kind of recommendations. If you think about the robots that we have that uses deep learning based models to figure out the best way to fulfill orders. So that's how we get our packages delivered in 2 days or 1 day or 2 hours or even 15 minutes now in certain areas. Extra vision you might have seen with Amazon Prime or Kindle, where the extra vision shows you a lot of insights into what you're watching or reading. Alexa, everyone knows Madam A. Luckily, I don't have it in this room. Otherwise, she would have said hi to all of us. So now our goal is, to bring machine learning to millions of developers. And how would we do that? So we'll see to that. But today, we have like tens of thousands of customers who are using it to solve real world problems. So it's not like machine learning is going to happen. It's happening in companies of every size and industry. And you can see a snapshot of some of the publicly referenceable customers that we have who are using machine learning to solve problems that are core to their business. And one of my personal favorite is this. If we have any football fans here, you might have seen Next Gen Stats. And the story behind it is, NFL started putting RFID tags on players' shoulder pads and in the game balls starting in 2014, which helped them to collect large volumes of tracking data, like the location and the speed and the acceleration and the distance traveled. And starting 2016, NFL began working with AWS to accelerate the NGS Next Gen Stats program to combine old data and the new data to reveal insights about the game dynamics. And in just one session, I think it's across 256 games and over 50,000 plays on the field, and that's a lot of data. So the most exciting part is, right, they're using all this data to build predictive machine learning models to highlight the athleticism like never before. And it's just getting data, just bringing data to life, right? So the obvious question is why I'm talking so much about the data. And the reason behind it is machine learning cannot happen without a lot of data and good quality of data. I want to emphasize this whenever I talk to customers and they're so excited about doing machine learning. I cannot emphasize enough that I have to help them understand that you need to have a very well-defined data governance strategy and historical data as well for your machines to learn something good and to do something good for you. Otherwise, if you have garbage in, this is garbage out. So now, if you have more and more devices generating terabytes and petabytes or even exabytes of data, yeah, you have the cloud solutions that gives you the computing to operate at this scale, but then the data needs to be cleansed. It needs to be prepared and it needs to be analyzed using different big data solutions like Hadoop and Spark and whatnot. And then once you have a good quality of data, that's where you use this as an input to the machine learning workflow. And by now, I think you guys understood our love at Amazon for different kind of flywheels. So you will see a couple of more of this. So with that background, let's talk about the machine learning stack at AWS. This is also like a 3-layer stack that we have. At the bottom of the bottom layer is the frameworks and interfaces and infrastructure layer for expert machine learning practitioners. So at this framework layer, there are 3 frameworks that are predominantly used: TensorFlow, PyTorch, MXNet, and TensorFlow has the largest community today, and we have a lot of TensorFlow experience and usage on AWS. Actually, 85% of the TensorFlow running in the cloud runs on AWS. But in reality, there are very few machine learning practitioners who use a single framework, actually 1 in 10. 9 out of 10 ML practitioners use more than one framework. And that is because new algorithms are being developed all the time in different frameworks. And people want to borrow from each of the frameworks. So what we did, we want to do the heavy lifting in ensuring that we give you different kind of algorithms available in all of the frameworks. So as a data scientist, you can actually focus on the job that you love to do. And you don't have to play around with and compromise using one framework versus the other. The second layer is where, when we meet with the customers, they tell us there are not that many machine learning experts in the industry. You don't get a lot of PhDs to come and work for you. And if you want machine learning to be pervasive, you have to make it easier for everyday developers and data scientists to build, train, and tune all this machine learning methods. And that's what the middle layer of the stack is for. We have built a fully managed service called Amazon SageMaker that removes the heavy lifting from each step of the machine learning process. And today, we are also going to focus on the SageMaker. And finally, the top of the stack, this is where we have built different AI services. That means this is where the developers like you can just come and if you want to add solution-oriented intelligence to your applications through an API call, just use it. You do not have to worry about learning all this machine learning frameworks. You don't have to train your own models. And we have customers that has been using this very effectively. So for most of the common use cases, like I have a image and a video and I want to know what is in the image, or if you are doing some security camera, you want to know like if is there a risk as someone is approaching the door. If you have speech use cases, text to speech, speech to text, doing transcribing, just use something like Amazon Transcribe. One service that I really like out of this, my personal favorite, is Code Guru. This is a new machine learning service that actually helps you automate code reviews and identify the most expensive line of your code. So if you have a big code base, hundreds and thousands of lines of code you have inherited, you have no idea how well the code is optimized, just use this machine learning service and it will tell you what are the most expensive line and you can focus on that. So you get the message. You can just use all those top layer services if you don't want to learn machine learning models, but want to use it for most common use cases. Now, let's come to the middle where I said that we have built a service which can help machine learning practitioners to build, train, and deploy their models, because in the future world, we might not have services for many of our custom use cases, and you might have to build and train your own machine learning models. So how do you do that? So as I mentioned earlier, having good quality of data is super important. That's a prerequisite machine learning process. If you do not have data, don't worry about machine learning, go get more data. But once you have collected and prepared your training data, as a developer, you need to figure out which algorithm or framework you will use to build this model. And once you have done that, you need to ensure that, okay, you train the model. So not only you have the scale and the compute and the horsepower, but you also understand about all these different kind of models. Then you need to integrate this model into your application, deploy this application on different kind of infrastructure that will scale, and that's what your process ends. So it looks like typical SDLC, right? I have my data, I build, I test, I deploy. What's new about it? The problem is what we take as granted as developers when building traditional software with like debuggers and project management tools and version control, collaboration, are all disconnected for machine learning. For example, while notebooks are great for individual developers, but how would you share all your work with your peers? Another example is model tuning, which can take days or even weeks for tedious work for complicated use cases. So typically to tune a model, you will start with something very random and iterate through adjustments to see how to change the model. And it can be a very, very long cycle and might not help for your faster time to market. So that's where we have built something called a SageMaker IDE, which kind of does a lot of these steps for you together, so you can build and test and debug and deploy and monitor and profile and do everything within a single environment. But at the same time, it's very modular. So you don't have to necessarily use all of these components. And since it's anyhow going to use all the open source frameworks under the hood, like TensorFlow, MXNet, PyTorch, or different kind of algorithms that we'll talk about, there is nothing, and Jupyter notebooks actually for running your ML models. So there is nothing like a lock-in if you guys think about it. So, and this is the first in the industry. No one has this kind of IDE today. So you have the flexibility now to build and automate a lot of the machine learning processes using a modular approach. These are some of the built-in algorithms. So if you see that we have a lot of algorithms for classification, for regression, you can use random cut forest for anomaly detection, clustering with k-means, computer vision, and whatnot, right? So we support both supervised and unsupervised algorithms. And if that is not good enough for you, well, you can bring your own. So just containerize your machine learning model and bring it to SageMaker, and SageMaker will run that for you. It's that easy. You don't have to just use the algorithms that is built in for you. But of course, when we see more and more algorithms, which are pretty common for most of the customer use cases, we'll continue to build more and more of those. But in the meantime, if you have very specific custom use case that many of our customers have, they will just bring their model and they will still take advantage of all the capabilities that SageMaker provides out of the box. Okay, so if you're thinking, well, I don't have the skill to build all this machine learning model and none of those built-in algorithms works for me. What do I do? Guess what? We also have a marketplace for machine learning. So you can just go there, you can, buy or sell hundreds of algorithms, your IP is protected, your data is protected using shared responsibility model. And many of the top players in this space are already contributing to this marketplace. So if you want to get your hands dirty with machine learning and make some money out of it and want it to scale or even make it just open source, you can just use the AWS marketplace for machine learning models. That's going to be awesome. Okay, so with that, now we talked about edge computing with IoT services, with Greengrass, how you can do all the local compute, local processing, machine learning, inferencing, all this good stuff on the edge. And then I talked to you about the machine learning side of the world, where you can use something like a SageMaker to build an end-to-end machine learning model. So that's great. So let's see how both of these things comes together. So SageMaker Neo is very interesting, right? This is where you can train your models using all these different frameworks. And then the SageMaker Neo compiler optimizes these models to run with twice performance, twice with no loss in accuracy, into different kind of hardware platforms. So it could be from Intel, NVIDIA, Qualcomm, you can read the list. So the models will be automatically optimized for each of these hardwares. And when you deploy on the edge with a single click, and I will show you how, it will even run, with less than a tenth of the memory footprint, which is awesome. And that's what you need when you go to microprocessors or even microcontrollers, which are very resource constrained on the edge. You cannot have a big fat machine learning model sitting there and doing the inferencing. So what this compiler does, the SageMaker Neo compiler, what it does, it actually uses a neural network to discover and apply different kind of specific performance optimizations that is needed for different hardwares, which will make your model run most efficiently on the target platform. And we have been working with all these different partners to do that. Karma is a great example. If you have not heard about Karma, look it up, where we actually partnered with BlackBerry as well in helping them to develop a AI solution for powering their cockpit experience. So it essentially helped them to orchestrate the vehicle sensor data with contextual information about the vehicle and the driver, running locally on a very safe QNX real-time operating system, and that is from BlackBerry. So you can see that you have the QNX layer. On top of that, there is a Greengrass layer where you run different kind of frameworks like TensorFlow and OpenCV, and finally that talks to the cloud when it needs to talk to it. But the cool thing is now all these models are deployed at the edge. It can work on its own without any cloud connectivity. That's the whole point, right? Once it is there, it's secure, it's safe, it runs on its own, it's fully functional. And you can update it from time to time, or you can get data from those devices as it comes online from time to time. So now, with this background, let's talk about some of the common use cases we see and some of the common reference architectures that can help you. So if we think about the consumer IoT applications, this is where we are all consumers of IoT applications. If you're using a mobile device, this is essentially a consumer IoT device. Or if you have light bulbs or door locks or thermostats or smart security system, they're all consumer appliances that is using IoT in some way. So let's say you have a security system where all your local devices are talking to that as a gateway. This is where actually Greengrass goes. So all these devices can talk over different kind of protocols, right? It could be Bluetooth, it could be a mesh network, it could be Zigbee, it could be Z-Wave and whatnot. As long as you're running the respective protocols, adapters on the Greengrass appliance, you can kind of do all this protocol conversion and finally send this data to the cloud using standard formats like MQTT, which is very lightweight, that's commonly used, but you can also use something like a HTTPS if there is a need to. And then on the cloud side, once you get all this data, there are different ways to clean up the data. You can buffer up the data, you can queue the data, you can process the data, and finally it gets stored into a data lake with something like a S3, which is our object storage. Or you can use a data warehouse like Redshift. You can do machine learning with SageMaker. You can use a NoSQL solution like DynamoDB, or if you want to run Cassandra and MongoDB, do that. You can run Elasticsearch. So many of the services are managed for you. And our whole point is making your life easier. Let us do the undifferentiated heavy lifting of managing the infrastructure and the scale, and you just focus on your business logic as a developer. So you just write your code that matters to your business and don't worry about the infrastructure. That's the whole point of cloud, right? And finally, all this data is made available to different kind of personas. It could be a consumer, it could be, field technician who comes and sets up all the security system, and they will have access to all the different capabilities through the mobile devices or whatever they use, to the web console and whatnot. For industrial IoT, if we have any industrial enthusiasts here, PLCs are pretty common, programmable logic controllers that generally talks OPC UA, but it can talk other languages as well. So KEP server is something that can read from all these PLCs, and it is in a OT network, right? So it goes through a firewall and talks to the edge gateway, which is probably in the IT network. And there, Greengrass is essentially running, and Greengrass gets all this OPC UA data. It sends to something like SiteWise, which is our industrial service, which can understand OPC UA data, and it still goes over MQTT though. And once it has understood the OPC UA data, it can also serialize the data to store into industrial data lake. And this is where you are collecting all this data. You can run analytics on this data. You can do machine learning on this data. You can have the data scientists and BI engineers who are, kind of visualizing the data, consuming the data. Also, another important thing is something called IoT SiteWise Monitor. It is like a web portal that we have built where you get a real-time view of, let's say, the OEE, operational equipment efficiency, and you have the operators and you have the production supervisors on the factory floor. They can have now real-time access to all this data in their factory, even in a closed network, and they will be able to kind of take immediate action rather than just strolling around, right? Which is generally done today with different like red, amber, green kind of signals. Okay, so seeing is believing, right? So with that, we have, I think, covered a lot, and now it's time for getting to the demo. So the demo that I'm going to show you, this is the architecture essentially. So on the left, we have the Greengrass core, and it's kind of hosted on a simulated environment now. It's running on a server on the cloud, but in the real world, you will essentially use a hardware to run your Greengrass. And what is happening, it is collecting different kind of images from the cameras, and you can see there is a data acquisition layer which periodically acquires the raw data and the inputs from an image source. Then you have the data preprocessor, which preprocesses the images by resizing them so that it's in the right format to train the model. There's an estimator which predicts the data input with the connector. Then the middle box here is a Greengrass connector process. So this is where the connector loads the model from the local Greengrass resource, and it invokes the model from time to time. Because now you have the machine learning model deployed onto the edge, you need a process to essentially invoke that model from time to time to do the inferencing. And there is a feedback connector. So a lot of the data levels that you can get may be raw, it's kind of unlabeled. So with the feedback connector, you can send all this back to the cloud, and it's unlabeled data, and then the unlabeled data can be labeled using Amazon, something like Amazon Ground Truth, which kind of helps you in automatic the labeling process. And finally, you also have the cloud side where you have the machine learning model, you have more unlabeled data, so you're continuously training your models based on the data that you are getting, and you're optimizing your model. So with that said, let's actually go back to the console and see how it really works. So this is the console for SageMaker that you can see on my screen. Let me make it bigger maybe. And this is where what I did in the interest of time, I had a training job which essentially takes a model and it got trained with lots of data that I got from public data set. And you can see that there are a lot of things here, right? There's an algorithm that is being used. There is the input data configuration. There is, the output and different kind of parameters that is being used. And then you can also monitor the metrics. So how did I come to this screen, right? So let me go and show you the Jupyter console. So this is kind of part of SageMaker again, and you can see that there are a lot of capabilities here. You can do a lot of configuration in one single IDE. This is what I was kind of alluding to before. And we give you a lot of sample Jupyter notebooks for you to get started with. So the Jupyter notebook that I have used is here, SageMaker Neo, and the full training high-level image classification example. So you can just quickly get started with that. And in the Jupyter notebook, what we are doing that whole end-to-end machine learning workflow process that I explained, right? You are essentially collecting all the data. So I have used a public data set. You can see the name here. It's a Caltech 256 data set. And I prepared the data using the data preparation, and it uses MXNet under the hood. Excuse me. And then the model got trained. Once I have the data prepared and cleansed, it's stored in a data lake S3. Is our object store, where you can see is the input location. We are also using S3 as the output location. I don't know if it is too small. I'm trying to make it bigger then. And then the hyperparameter is interesting. This is where, as a data scientist, you need to ensure that you are choosing the right batch, you are choosing the right number of epochs, the learning rate. You have to understand all of these different pieces. But you can easily get started with some of the samples, fine tune and see. Also, we are specifying a training instance. So this training instance is a machine learning P3 instance, which will be launched during the training. And once the training is complete, the instance will go away. So it will be automatically terminated. And once the training happens, which is here, we start the training. The evaluation piece comes in, right? So this is where this is where the model is now trained, the model is available, and you do the inferencing on those machine learning models to predict something for you. So in this use case, we are going to predict based on the image, whether it's an American flag, whether it's a baseball bat, whether it's a bear or whatever. And finally, you do some kind of cleanup. And now, if it has to run on the edge, so the entire process that you just saw in the Jupyter notebook, you got the model, you can now use it both in the edge on the cloud, right? But for the edge, as I was mentioning, you need to ensure that the model is optimized enough, because you do not have a lot of hardware resources. So that's where you use something like SageMaker Neo. And with SageMaker Neo, you can specify how you can optimize this model for the edge. So it could be something like a green grass, or down the line it could be something like a TinyML running on a microcontroller. But you can kind of optimize some of these models, and the model will be deployed again back to the edge to make the predictions. Okay, so what I will do, I have already trained this model, but to show you guys, I will also just keep it running if it is finishes by the time we're done. So I will just run all the cells, and you see that all the star marks here in a Jupyter notebook. If you have used it, you know about it. If not, essentially star means that it's kind of getting executed. So you see the first two steps just got executed. The third step is now getting executed. So we'll come back to that. So now you have the machine learning model, and it's being kind of available as an artifact, as an executable in the object store like S3. You go back to IoT, right? How do we bring AI and IoT together? That's the whole point. So here in IoT, we have the Greengrass console, and I have created this Greengrass group. And in the Greengrass group, it's essentially, a deployment group. It has a lot of things. So it has a subscriptions, which means how all the orchestration will happen on the edge. You have to define that. You have to tell us that, okay, I have 3 Lambda functions that needs to process the data, and this is how the routing should work on the edge. So that's what you specify in the subscription. Then you add different kind of devices here. You have a Lambda function, which is essentially a serverless function, which is written in standard Java, Node.js, Python that you can deploy on the edge. So I added the Lambda function. I added the machine learning resource here. So this is the machine learning model that is being trained, and it will be deployed onto this edge server as well, along with the Lambda, which is the compute for the processing. And then we have the connectors. And this is a connector which essentially do the model inferencing and also sends the feedback to the cloud on the unlabeled data that I talked about. So those can be labeled and can be used for training the machine learning model again, because it's a continuous process, right? Remember the flywheel that we are in love with? This is the reason, because it's a continuous process. So now once you have added all these configurations, what do you do? Super simple. I have already deployed once. You go to actions and click on deploy, and this deployment will start, and it will again go back to the gateway. So I'll come back to this. So now this is my gateway just for this presentation. I have logged in. It's actually a server running on the cloud now, but in the real world also you will have something Linux based, or if it is Windows based, you might run Docker and whatnot. So what you see on the screen are different things. So if we start with the left top, this is where all these resources that I just click deploy goes into on the edge of the server. So if you see the ML model, this is where we have the executables for the machine learning model that is being trained on, that was on the cloud, and that is now deployed on the edge. If we go back to the Lambda, you see that these are the different functions that is being that I showed you in the Greengrass group, where we had a ML feedback, a classification image, and a Lambda function called pinned accelerator that is all deployed on the edge. So that means even if this device is now completely off the network, since it has all this compute power, the machine learning model, the subscriptions that has been deployed, it will continue to work. What you see here on the right bottom is a system log. So this is where you see that what is essentially happening. So you can see that there is a GG router, which is a Greengrass router, and it is doing all kind of feedback processing and image processing and whatever is happening. There are also additional logs that is there, but I will just skip it in the interest of time. And finally, once these predictions are happening, you need to see it in the cloud as well, right? You might need to have real-time monitoring of what is happening. So that's where this is MQTT client. I'm just subscribing to one of the topics, and it's doing the inferencing and sending all this inferencing results from time to time. And you see the confidence, right? If the prediction is a soda can, the confidence level is really low, 17%, versus if the another soda can, the confidence level is 84%. So as a data scientist, you also need to monitor this and see that how many predictions are probably having a higher confidence versus lower confidence. If most of your predictions are lower confidence, that means your machine learning model is not well trained, and you need to collect more data and keep on training your machine learning model until it's optimized. So that's in a nutshell. Now, the obvious question is, Neel, how do we get started? This looks good or okay, but I need to get my hands dirty as a developer. So we have a lot of resources. If you can just go to this link, and we actually had a machine learning university internal to Amazon that has been used for many years to train our engineers on machine learning. And last year, we made it available to all our customers. So you can go there and you can enroll and you can learn a lot of machine learning stuff just for free. And also we have, the development kit. So if you see a little car over here, this is for reinforcement learning. We call it Deep Racer. There is this one called Deep Lens. There is a keyboard as well. So if you can buy one of this, and that can help you to play with different kind of machine learning models. If you like to get certifications, we have a machine learning specialist certification. Also, there are courses available in Coursera and edX and Udacity that you can go and get certified as well. How do you get started with IoT? Same thing, our internal training library is available to all of you guys now. So go there and learn about IoT. Go if you want to, get a certificate. Today we do not have an IoT certification specialty from AWS, but you can go to edX. We have a course, and luckily I was a trainer on that course as well. So if you don't hate me by now, you can just go and probably see some of the trainings that we have there. I was one of the trainers there, and you can start with a kit like a Raspberry Pi or Edison or Arduino or whatnot. Or if you want more sophisticated hardware devices, you can also go to the device catalog. that we have, where our partners like Microchip and XP Qualcomm have their development kits, they have their production grade kits, and you can look into that as well. So that being said, we covered a lot, right? We kind of covered why edge computing is important. You do all the data collection and model inferencing, machine learning inferencing there. Then the data is transported and routed to the cloud, where you do the aggregation, enrichment, cleansing, and everything. Based on that, you fine tune and optimize your machine learning model again, generate new models maybe, and then deploy over the air back to the edge where it continues to process. So that's why, when I said before, it's like a cycle, because again, it's a continuous process. And remember, data is more valuable when it's adjacent to other data sets. So you perform analysis and machine learning training in the cloud, but inferencing at the edge opens up greater capabilities, like with autonomous vehicles, right? So that's why, probably we have been very innovative in coining the term AIoT, but hopefully it helps you to reimagine your use cases that was not possible before. And now, that you know the state of everything using this approach and can reason on top of your data, I would be super interested to see what problems will you solve. And I will open it up for Q&A if we have any questions.
Thank you very much, Neel. That was really awesome. If anybody has questions, can you please post them in the RoomBee Slack, and then I will ask them to Neel so we can answer them for everybody. We have about 3.5 minutes left, and as a reminder, this will kind of have a hard cutoff. I actually have a quick question. First is, I actually didn't know that AWS had a marketplace where you could get data. So now is that like training data for training sets, right?
Yeah, that is called AWS Exchange. So that's where you can have, that is your marketplace for data, and then we have marketplace for machine learning as well.
Okay, cool. Yeah, I was actually unaware of that. Do you have any websites that you use to get maybe like free data just to practice kind of some machine learning stuff at home?
Yeah, the Kaggle, pretty common. You can go there and download a lot of public data sets. So I use that often. Okay.
So yeah, I guess that's that. Thank you so much. This was very informative. I know I thoroughly enjoyed it, especially as someone who's been looking into IoT and machine learning and all that stuff. So thank you so much. We greatly appreciate it.
Yeah, glad you joined it. So I'll just like to finish on one note. Steve Jobs once said that great work is not done by an individual, by a team, and I really appreciate Chariot is doing such a great work in this crisis. And I'm sure if we also do our due diligence in supporting you guys and supporting what is needed at this moment with social distancing, so we come out strong of this. So I really would like to appreciate all of your time again, and stay safe. Thanks for joining, and let's maintain social distancing.
Thank you. Thanks, Neel.